Hello, hello, and welcome to CodeLabs, pre-show, pre-workshops, whatever it is that we want to call it. But welcome. We are really excited, and by we, I mostly mean me, because I am sitting here day after 4th of July. I hope you all had a good illegal fireworks day. Today we're going to be talking about how to make a video game. And if you've been to something like a code day before, you might know the gist of how to make a really basic introductory video game. But today we're actually going to be talking about how to use a really cool tool that actual professional games use called Unity. Let's go ahead and jump right into it. I'm going to go ahead here. You should be able to see my desktop now. If you do have any questions, go ahead and post them in the Twitch chat. I got my laptop over here with the chat open, and so if you have any questions about what's going on, we can go ahead and answer them. So first thing we would need to do, if you haven't done this already, is download Unity. And I'm going to go ahead and search for it, go to the website, and what you would want to do is you would want to click Get Started, try Personal, which is the right-hand one. You can confirm the thing, and then it'll download the free version. Now, I will warn you, if you haven't done this yet, this will probably take about an hour or two to download in full, depending on your internet connection speed. It is not small. And so that is something that it's unlikely that you're going to be able to get through all of that right now. So that said, even if you haven't installed Unity ahead of time, this will be recorded. It'll be up on our YouTube page, and you can go back and take a look at it later and use that as an example. So I have already installed Unity. I'm not going to make you sit around and wait with me for an hour or two. I'm going to go ahead and minimize out of this. And you can see right here is my Unity window. Now, you would normally just double-click on the desktop to start that Unity project. I will also warn you, Unity, as with most IDEs today, IDEs being development things, tend to have a lot of bugs. And especially I've noticed on Windows, Unity has a lot of bugs. So hopefully we won't hit any of them today, but if we do, we'll do our best to get around them. So I'm going to go ahead and create a new project. We're going to give it a name. We'll just call it CodeLabs. And we can choose a location. Now, most of these are not going to be relevant. High definition render pipeline, lightweight render pipeline, these are for like professional game makers. Because again, Unity actually is used in professional games. I think if you go to the Unity website, you can get a list of some of the things that have been made on Unity. Yeah, here we go. So there are a bunch of professional games that are made on Unity. We don't need most of the things that are going to be involved in that. So we're just going to go ahead and choose either 2D or 3D. Now, I'm going to choose 2D. 3D, you might think one extra dimension, maybe it's 3 halves as complicated as a 2D game. That is not true. There's a lot involved in a 3D game. So we're going to pick 2D, give our project a name, go ahead and click Create. And we'll wait for it to start. Unity will take a little bit of time sometimes. Like I said, it's not a small application, and sometimes you will have bugs, and that's just the unfortunate reality of things. While we're waiting, I can go ahead and talk a little bit about what it is that we're going to do. We're going to make a simple 2D platformer game where you can run and jump. Now, if any of you have been to a code day, you've done the intro workshop at code day, you might remember that in the intro workshop, we can do that in like 5 minutes. Unity, it'll probably take us 15 or 20. It's going to be a little bit more complicated. On the other hand, we get a lot more flexibility. We can do a lot more complicated of things. So there's some trade-offs either way. Go ahead and continue to wait for this to load. Like I said, Unity is. While it's doing that, one other thing we can take a look at. So we're going to need some character art. One thing we could do for character art is we could make it ourselves. We could just use something like Paint. We could use Photoshop, whatever. For a 2D game, all you really need is a PNG image. Another good resource, if you haven't done that before or you don't consider yourself an artist, there's a great website called Open Game Art. It's opengameart.org. And this is a really great website for finding characters. So the ones that I'm going to use as an example for this was I searched for platform. I believe I searched for platform. I might have searched for tile. Gotta try. Well, I don't even know. It might have changed even since the, a few hours ago when I created the demo. The other one I did find was Robot, and I used this one. But you can use anything you want. We're not going to get into sprite sheets. Sprite sheets is when you see all these guys lined up like this, where you can do animations, kind of like a flip book. But any simple one for right now is going to be fine. And if you do want to use a sprite sheet later, there's plenty of tutorials on how to do that online that you can find. So now we're going to go ahead and jump into the Unity editor. This is our editor. As with Construct, if you've gone to a Code Day introductory workshop, this area right over here is going to be our world. It's going to be where we put everything. Down here is actually where we keep track of our, concepts of things. Unity calls these prefabs, but we're also going to have some other things, and we'll get into that in a little bit. Over here on the left is kind of a representation of the world as like a tree view. So you can think of this as like, if you've ever opened a File Explorer and you have like, Windows Explorer, you have the thumbnails, but then if you sort of scroll out, you can make it show you a list. This is kind of like that list view. This is kind of like the thumbnail view in a sense. I mean, it's a little bit more complicated than that. And then over here on the right-hand side is where we can configure individual things in the world. So if I click on this camera, for example, you can see here's the default camera. Now, we might want to move this around later, but for right now, because we don't want to accidentally move the camera, I'm just going to turn off visibility, which it's still there. It's just not going to move around. So first thing we're going to need to do is pull in some of our art. Now, remember, I grabbed that art from Open Game Art. You can make it yourself, whatever you want. All you need is a PNG. Now, I'm going to go ahead and right-click and click Import New Asset. It'll take a second. There we go. Cool. So we're going to go ahead and pick robotstand.png. This is going to be my player character. And we're going to go ahead and import a new asset, and we're going to import this block as well. Now, again, we got our camera. Our camera is looking at the world. You can see things. I'm going to go ahead and put our player character just sort of right in the center of the world. And I'll go ahead and put a block down here as well. Now, a few things to get started with. If you're ever making a pixel art game in Unity, I feel like this is really good to know. It's really hard to Google for. So even though this isn't the most introductory, it's still helpful to know. If you're making a pixel art game where you don't want things to get blurred if they're zoomed in, we're going to go ahead and click on it down here. Not up here, not in the world. Down here, we're going to click on this. And where it says filter mode by linear, we're going to change it to point. We're going to do the same thing for the block. Click apply. Do the same thing for the block. We'll change it to point. The other thing we want to do for the block is we want to set it to polygon, and that will help it make it tileable, which we'll see in just a second. We'll go ahead and hit apply for that as well. So when we're ready to try our game, we hit play, and it'll actually flip over to this game tab. Now, there's nothing going on in our game. We're really far zoomed out as well. One of the cool things is you can actually edit things in real time. So let's say we want to zoom the camera in a little bit more. We'll do -1, -1. That didn't really change much. We'll also try changing the size of the camera to 1. There we go. It's a little better. So now we're zoomed in. Now, if I were to stop the game and restart it, the camera will actually reset. So it's actually kind of neat. If you just want to test something out while the game is running, you can make changes, and whenever you stop the game, it will reset. On the other hand, if I want to make those persistent, once the game is stopped, I'll click on camera, and then I'll set the size to 1 again, and that should persistently now set the camera size to be zoomed in to the amount that we want. OK, so we don't have the world's most fun game yet exactly, but we can start to do things. So first of all, we want to make this a little bit wider. And I believe it should be in here. I thought it was in there. Oh, here we go, draw mode. So over in the actual world itself, we're going to want to change draw mode to tiled. And then now we can go ahead and pull these out. So now we got our floor, right? Great. And we'll talk about how we can make more floors later. You're going to need something called a prefab, but we're not going to get into that just yet. The second thing we want to do is we want to make our character able to move up and down and sort of be affected by gravity by default. Now, there's 2 things that we're going to need to do that. Luckily, both of them are built into Unity. First of all, we're going to need to tell it to be affected by gravity. And Unity is going to call that a rigid body. Anything that is a rigid body is affected by gravity in a sort of simple way. You can imagine it as like bouncing a baseball or something like that. It doesn't, it's not like a string. There are ways to do other ones, but anything that is rigid like that, we're typically going to call a rigid body. And I'm going to go ahead and we'll just switch over here so you can see my screen a little bit better. So over here, there's this add component. Now, any behavior or like thing that is important to an object is going to be over here in this add component section. We call them components. And some of them are going to be built in, and some of them are going to be things that we are going to make. So I'm going to add a component. I'm going to make it physics 2D because we're making a 2D game. Common confusion, physics, it would be better named physics 3D. And the reason it's not is because Unity was originally just for 2D games. So we're going to go ahead and pick physics 2D. And we're going to go ahead and find in here rigid body 2D. There we go. And you can see there's a lot of information in here: mass, drag, angular drag, gravity scale, simulated, all sorts of other things like that. Constraints. Here's a common one that you'll want to know: freeze rotation. Because our character is not going to freely spin about, we can actually go ahead and freeze his rotation. So I'm going to go ahead and start that. And we'll see that he will fall, and he will actually fall through the floor. And that's because if you've ever taken the intro workshop at Code Day, we really like to stress this: computers are really dumb. Computers are going to do exactly what we tell them to do and nothing more. So we've told the game that this guy's going to fall, and we haven't told it that he can hit anything. So in order to have him hit something, we're going to need that second piece. So remember, I said the first piece is what makes him fall. The second piece is what makes him collide with things. And it's also in physics 2D, and it's called a box collider. Now, there's other types. There's a capsule collider, a circle collider, all sorts of different ones. But what we want right now is a box collider because it's the simplest. So you can see the border turned green, and that's because that's actually his collisions. Now you can see that he is much bigger than his collisions should be. So I'm going to go ahead and hit this button, Edit Collider. And we're just going to go ahead and move it in so it looks like he's actually touching the floor. And we'll move it in on all of these sides. And we'll go ahead and move it down here. Now there are going to be some problems. As you can see, for example, all of this he would collide on. So even if he might have missed a hit, for example, later, he would take the hit. Not always a good thing, but it's going to work for right now. We could choose other types. I think there's a thing called a polygon collider. We'll take a look. Polygon collider, which will let you make more complicated collisions, but the game will actually run a little bit slower. So now we can see the green outline is right here. Now what's the other piece of this puzzle? We have him being able to collide with things. What we don't have is the ground being able to collide with things. So we're going to go ahead and add component, physics 2D, and collider 2D. Box collider 2D. And you can see that by default, it puts this little, it's a little bit hard to see, but there is a green square right there, right around the middle. Now we could manually resize this, or we can just click auto tiling, and there we go. Now it'll automatically make it the entire width of our tiling sprite. So if I go ahead and run the game now, we are going to see that he can stand on the floor, kind of. His feet are off of it a little bit, but that's fine. What doesn't work yet is movement controls, which is something that we're going to get into later. One more thing before we do that, by the way, you can move around with middle mouse button or by choosing your movement tool over here. I like middle mouse button. Before we get into movement controls, one thing I want to talk about as well is what Unity calls prefabs. So we have this floor out here in the world, and what we want to do is maybe we want to make more floors. Now we could copy and paste it, but if we have multiple different levels or something, that's not ideal. If we want to change something in one place, maybe we don't want to change it in others. Let me give you an example. Let's say I forgot to turn on auto tiling, so it's not going to work. Now what we're going to do, we're going to right click on this. We're going to click, we're going to drag it down here. And you can see when we drag it down here, it makes this new thing called block. I'm going to rename this to platform. And I'm going to go ahead and delete this existing one off the world. So now we have our platform type down here, and you can see down here it's a little bit hard to read because I couldn't make the text any bigger in the Unity interface, but it's .prefab. So prefabs are things that you can just drag in the world. It's kind of neat. So I'll just go ahead and put this over here. Now, again, the problem with this prefabs is that I forgot to turn on auto tiling, or rather, I intentionally turned it off. If I go ahead and set it down here, now all of a sudden, my my platform over here gets this. So I'll go ahead and turn it off. I'll show you again how this is useful. We're going to make a second platform. You can see now that both of our platforms, let's go ahead and move this, both of our platforms do not have the correct collision type. We're going to go ahead down here, click on our prefab that they both came from, auto tiling, and now both of them get the correct collision, which is great. Now I could manually turn it off on one of these, which is kind of neat. But all of the, if I continue to drag in new ones, they're all going to get the default one. So we'll go ahead and undo that. There we go. Cool. So that's prefabs. We could do it for enemies. We could do it for whatever we want. It's going to be useful. It's going to be one of the more useful things in the game. Now let's go on to motion. So motion is another one of those things that is very commonly used in games. Unfortunately, to some extent, unfortunately, I should say, unlike something like Construct, Unity is not actually going to go ahead and make super, super easy for us. So unlike something like Construct, where we can just give it a movement behavior, we are going to have to do some of the movement ourselves, but that's OK, because it's actually not as difficult as it might otherwise seem. Now, Unity has two options for programming, C# or JavaScript. Most professionals that I know use C# for Unity programming. That's kind of the recommended one. I think JavaScript is considered legacy. It may be removed at some point. In fact, maybe it's already been removed because I don't even see the JavaScript option anymore. But what we're going to do to create a script for our character to move around is we're going to right-click down here in this assets area. We're going to click Create, and we're going to click C# script. We're going to rename this, instead of new behavior script, let's rename it to something like player movement behavior. There's a tradition in Unity of calling things that affect the behavior of something, just suffixing them with behavior. That's what we're going to do as well. So I'm going to double click. It's going to open an external editor for C# code. And with any luck, this will work. This was giving me some trouble earlier. So we will see. Perfect. So I'm going to go ahead and load it over here. And there we go. And we'll zoom in a little bit more. So let's see if this is working. Perfect. OK. So we have our script up here. Basically what's going on, and it's got some comments here to this effect. You can see start is called before the first frame update. So basically start is going to be called at the beginning of the game. Update is going to be called every single frame. So what exactly does that mean? Well, when I hit run on this game, what's going to happen is any object, every single object in the game, for every single behavior that we have attached to it, any one of these scripts, every single one of them at the start of the game is going to run the start function. So you can think of it as kind of like a for each loop. Unity is going to do a for each loop, or a for loop, over every single object in the game. This guy, this platform, and then in each one of those is going to go through every one of their behaviors, and then in each one of those behaviors is going to call the start function. And then separately, once that's done, every single frame of the game, which for most people will be 30 frames a second or 60 frames a second, every single time, as fast as it can, basically, it's going to call this update method. So every single object in the game, for every single behavior it has attached, every single frame, it's going to run this method, which is kind of crazy when you think about it. It's a lot of function calls, right? Now, what do I mean when I say every object that has it attached? So this is going to be our player movement. And we've put it down here. What we're going to do now is we're going to click on our player object. We can click on it here or here. And we're going to just go ahead and drag it in. Drag it in right there. Now, all of a sudden, if we run this game, now nothing's going to happen. But if we run this game, this method is actually secretly being called every single frame. And right now, it does nothing. Now I think there are some things we could do. I believe logger dot debug dot log. This is a frame. Go ahead and save that. And now, if you give the game just a second, you can see, look at all of these log items. So again, every single frame that it managed to run, it ran that, hello, this is a frame. Now, obviously, that is not actually very useful to us. So we're going to do things that are a little bit more complicated. We want to have movement. So the most basic version of movement is we're just going to allow, to start with, the ability to move right. Now, what do we need to do? Remember, every single frame, we need to write a method that's going to happen every single frame. So saying something like, when I press right, start moving right. When I stop pressing right, stop moving right. That's not how we do it. Typically, again, I'll write this down as an example. When I press right, move right. When I stop pressing right, stop moving. Now, that's how many of you might intuitively think of something, how this would work. And that would be what's called event-based programming, or what I like to consider event-based programming. The game would tell us this has happened, and then we would decide what to do about it. That is not what's going on here. Instead, again, what is going on here is that every single time, every single frame, something is happening. Every single time someone is, pushing a key or not pushing a key doesn't matter. What's actually going on is the game is just constantly running this method. So instead, we need to say basically every single frame, am I pressing right? If so, move slightly right. This is what we're actually going to write. This is the code that we're going to write. So if it looks confusing to you, it's because you might be thinking about it in this way, but that's not the way that Unity works. I'm going to go ahead and get rid of that. This is what we're trying to code. And in fact, it is actually going to, this is what would, up here is what we'd call pseudocode, something that looks like code. But we're going to write something that actually looks a lot like that. So if input dot key down, is it get key? Yeah. So key code dot right arrow. And then, so now what we've done is we've said, if the right key is down, we're going to do something. And so again, we can go ahead, let's for right now do debug log right key is down. 3 exclamation marks just for emphasis. We'll wait for this to go ahead and load. We'll hit play. This console down here is going to automatically clear itself, or it should. And I'm going to hit right. And you can see, even in that very short amount of time that I hit right, it had 1, 2, 3, 4, 5, 6, 7, 8, 9 frames that were actually going and running right there. So again, if I continue to hold down right, you can see that the scroll bar actually gets tinier and tinier because it is running at every single frame. Now, we don't want to do that. What we want to do instead of debug.log is we want to actually move the character. Now, what we need to do is we need to tell the rigid body that we want to add a force to the right, effectively. We want to apply a force that's going to move him to the right. That's my right. I guess that would be your right. But we need to apply a force. So the first thing we need to do, we always apply forces to rigid bodies because rigid bodies are a physics thing. Now, we could technically move the entire model, but that's going to lead to some problems later when we want to make him jump. Because when we want to make him jump, we want to make him smoothly jump up and smoothly jump back down. And if we were to just move the entire image, that wouldn't work. So instead, what we're going to do, like I said, is we're going to apply a force to the physics itself. The way we do that is we do getComponent is the name of the method. And by the way, if you're wondering, if you haven't done C# before, it's kind of like saying this.getComponent. If you're used to something like Python or something where you'd say self, that's what's going on. We can omit that in C#. I'll leave it here just for clarity. we're going to get a component. And what we need to do as well is we need to tell it what type of component we want to get. Now, C#, instead of passing in a parameter, when we want to pass in a type, we do it inside of these pointy brackets before the parentheses. That is the way that C# works with types. So if you want to pass a type of something, I'm not being entirely truthful here. There is a little bit more complexity to it, but that is effectively what we are going to want to do. So what we're going to want to do is this.getComponent, rigid body, 2D. That's the same name as the other thing that we were talking about as well, right? Cool. So now we've got the rigid body, and let's go ahead and store in a variable. And in fact, let's just go ahead and move it out here. We'll just name it RB for rigid body, and we'll go ahead and semicolon there. Now, if the key is a right arrow, we want to move that rigid body by adding a force. So I think it's just called add force. And it's going to take what's called a vector 2. Now, a vector 2 is a way of saying, fancy way of saying the x position and the y position. So if we wanted to, what we could do is new vector 2. And you can see down here, it's a little hard to read because I couldn't make IntelliSense bigger. Float x, float y. Basically, if we want to do the x position and the y position, I believe x is 1 and y is 0, right? Because y is the up-down, x is the left-right. We will see if that is right or not. And then the question is right positive left, or positive or negative? But it should do something at least now when we go ahead and hit the run button. Maybe not. So let's try. It might just be that he wasn't able to overcome friction. He does have the player movement behavior script, so that should actually work now. There we go. So he just wasn't able to overcome friction. And let's just go ahead and set his x back to 0 or -1. There we go. Now, there we go. He hits the thing. So that is a possible way to do it. I'm trying to figure out what order I want to talk about this in. Let's do this first. So instead of doing this, because it's kind of confusing to remember left, right, up, down, what's what, there's another fancy way to do it, which is to do vector2.right. And that's going to, by default, make it a 1 unit. So it's going to move 1 unit to the right. What are those units? I think it's definable somewhere. It's like pixels per something. If we want to make it 10 units, we just multiply it by 10. So times 10. And this should do the same thing. So we'll go ahead and run our game now. And we'll see that now I can move right again. Now, how will we go ahead and move left? Well, same deal. Else if input dot get key code dot left arrow rb dot add force dot left times 10. Save that. Go back to our game, wait for it to finish loading, and we'll go ahead and hit play. Move right, and we can move left, but this is like a little bit extreme, right? Like my force is a little bit extreme. It's moving a little bit too fast. So what we can do instead of doing this times 10 is we could do like times 5, right? But then you can see now, oh, okay, over here I need to change this in every single location. That's kind of annoying. What would we normally do in programming? We would normally make a variable. So we could call it variable speed is equal to 5, right? Cool. We could do that. Now here's the thing that's really neat about Unity. Every time we want to change the speed right now, we would need to go into this code. And if we had characters that could move at slower speeds, we would need to make a copy of this code and keep it all up to date, which is kind of annoying. So instead, what we can do is we can make a variable up here. We can make it an integer. It's called speed with a capital S, and it's by default equal to 5. Delete this. This.speed. This.speed. Go ahead and save it. Now check this out. When we go back to Unity and we wait for it to load, give it a second. I'm going to go ahead and remove this and try adding it again. Go ahead and add this. It's not actually working for some reason. Let me go ahead and check really quickly if Unity changed this. We will take a look really quickly. This should work. We can try public, just in case. Just in case that is actually required for it to pick it up. It's still not picking it up for some reason. Oh, there we go. OK, perfect. So you can see down here now, the speed is actually set to 5. I can actually go ahead and change it in here. So let's go ahead and start the game. And remember how I said we can actually edit things inside the game? This is a really neat example of that. So like I said, this is a little bit too fast. Right? So what we can go ahead and do then is we'll click on our robot, and we'll just change the speed to 2. And we'll try that instead. Oh, it's a little bit too slow. So maybe we'll try 4. Not bad. OK, so we'll go ahead and stop that there. We can also do something like a max speed by checking if velocity is greater than, here public and max speed equals, I don't know what units those are in again, but we'll try it. If RB velocity is greater than this.max speed, RB.velocity is equal to RB.velocity divided by what we want to do. I won't actually get into this, because what we would need to do for velocity is we would need to figure out what the we need to figure out the magnitude of the velocity, and then we would need to actually multiply it by the amount that we want to decrease the velocity so that it continued to be in the exact velocity. Or we could multiply at this point, we're getting into a little bit more complicated things. I won't actually get into that right now because we are running a little bit short on time. But anyway, let's actually get into jumps. So if we wanted to do a jump, we might want them to be able to press right and jump at the same time. So I'm not going to do that else. If input get key code arrow rb.add force vector 2 dot up. Where's my keys on Dvorak? Up times, and we'll call this public int jump height, or jump force. And we'll give this equal to, let's say, 20, because I think gravity is equal to 9.8 in this game by convention. So jump force. Perfect. And we'll go ahead and save this. And again, we can go ahead and tweak this if we don't like exactly how it's winding up either. So I will run the game. You can see that it's updated with those 3 properties actually showing. And OK, so maybe 20 was a little bit too much. Now, one of the problems with this, again, is that we have this, we have this if the up arrow is being pressed, but that's sort of constantly going to be being pressed. One thing that is nice for us is Unity can tell us like the first time it's pressed when it changes states, and that's by doing isKeyDown. or GetKeyDown, which will only happen on the first frame that a key is down. And you can see during the frame that the user starts pressing the key. So that'll, I think 20 might still be too much, but that will stop our problem of our character sort of infinitely accelerating upwards when we're holding down the up key. It won't prevent double jumping, but it will stop that. Okay, so 20 was actually way too little, but you can see that I can't continue to accelerate. So we'll try 200. There we go, not bad. Now I can double jump. That was a little bit too much. I can double jump. We'll try 50. Go ahead and run the game, and I'll show you how I can double jump. And so if I hit this button fast enough, I can actually fly. 20 is a little bit, sorry, 50 is still a little bit too small, so we'll try 100. Yeah, so you can kind of see how I can actually fly. Now, if you're making Flappy Bird, this is totally fine. But obviously, it's not perfectly fine for this game. What we would do there, and I'm not going to get into exactly the details of how to do it, what we would do is we would need to check if the player is touching the ground before allowing them to jump. Or we could store a jump counter and say they're only allowed to jump once between touching the ground. And if you were to go online and Google that, let's say Unity allow jump, let's say Unity don't allow jump in air, you will see that there are ways to do this. There are good examples of how to do this. The tricky part, again, is remember the update is called every single frame, and so there are other ways to do that as well. There are ways to keep track of the collisions separately. A few other things we could do, for example, let's say we wanted this component. GetComponent is called every single frame, which is a little bit silly. So what we could do up here is we could make a private rigid body 2D is equal to null. And then, or we could just leave it undefined. Over in start, oh, and we forgot to give it a name. Over in start, you can say that RB is equal to this .getComponent. And now all of a sudden down here, this code is a little bit more efficient, and many things might actually need rigid body. Now again, I don't need to do this. I like it because it makes it a little bit more clear where that's coming from. So we have our thing. Now, again, we could technically add this to multiple things. So if I were to take this player movement, and I were to drag it onto our platform prefab, let's go ahead and open platform, and I will drag it in here. Now, all of a sudden, and this will make no sense whatsoever. Actually, this won't work because our platforms do not have rigid bodies. So that actually won't work, because we didn't add a rigid body because we don't want them to be affected by gravity. But in theory, if you had multiple players or something like that, you could add it to them as well. So if I were to go ahead and add a open game art, and we were to come up with a second robot, this guy looks okay. He is animated. We'll do this guy. Let me save it. There we go. So we'll go ahead and save him to our desktop. Go back over here. Import him as an asset. Drag him onto the screen. That's a little bit big. 0.1, 0.1. We'll do 05. Okay, not the world's most beautiful thing. I don't know why they made it a transparent PNG if you're going to add a white background, but that's okay. What we could do now is if we were to add onto him a physics 2D box collider, we were to add onto him a physics 2D, where are we, rigid body 2D, and we were to drag onto him also the player movement behavior, you would see that both of these two would actually move at the same time, which is kind of neat. Now, of course, they're both going to move on the same keys, which is probably not quite what we want. I didn't lock his rotation, by the way. If you remember, I said something about freezing rotation Z. Not quite what we want, but again, we get these really cool public int things where when I make something public, it actually does show up down here. So what I could do is I could say public key code. Sorry, what is the actual type that it needs? Yeah, it is a key code. Left key equals key code dot left arrow public key code right key equals key code dot right arrow and public key code jump key is equal to key code dot up arrow. Go ahead and replace these with left key. Sorry, I think that's right. Right key, left key, and jump key. So we go ahead and replace those. Now when I go back into Unity, Unity is going to very neatly let me see what keys are controlling each player individually. So you can see now over here, they're both left arrow, right arrow, and up arrow. But if I were to change this guy to, let's say, well, this is going to take a little bit to scroll, isn't it? I'm just going to use ABC because it's near the top, but you would probably want to use WASDA. A, B, and jump key, let's just make return. And where is my B key? It's over here. So now all of a sudden, this guy moves with A and B and jumps with the enter key. Kind of neat. And this guy still moves with arrow keys. So we have just made a potentially multiplayer game, again, on one keyboard, but it's kind of neat. And so that's why you would want to do things like use as public parameters. You can actually reuse these player movements, which is super, super neat. So what are our next steps exactly? Let's go ahead. I will switch this back to me. So what are our next steps here? Unity is a little bit more complicated than something like Construct. You're not going to get a game that's really very playable in an hour. It's probably going to take you more like a few days. That's why we don't really recommend this at Code Day, but we do recommend it at CodeLabs because it does work out well. If you have enough time, you can make really, really cool games with this. That said, again, if you're looking for instant gratification, I would probably still recommend something like Construct 2, or Construct 3, sorry, or Game Maker or something like that. That gives you a little bit more built in. But Unity, because it doesn't give you quite as much built in, it does have a lot more tools to help you build really, really amazing games. And so a lot of really, really popular, well-known games are actually made in Unity, which is super, super neat. So you have access to the same tools that actually professional, game studios do really use. If you have multiple people, there's actually right up here, there's a collab button. And so if you were to click on this, you can actually edit with multiple different people, which is super neat. There's a lot of features in here. It's just going to take you a little while to get used to them. So what I would recommend is just go ahead and get started. Use probably a 2D game because 3D is a little bit more complicated. But go ahead and get started, see what you can make. And as you have questions and you're not sure what to do, remember that every single person who is a professional programmer Googles things daily. So feel free to do that, and feel free to ask for help in the SR&D live chat. This video, if you need to go back and reference anything, will be uploaded to our YouTube very shortly. And other than that, in about 15 minutes, we're going to do a completely unrelated video on introduction to web development. So I hope to see you at that, and I hope to see what cool projects you make. Start to think about what projects you want to be doing if you haven't already gotten a decision. And we'll see what you make in the next 2 weeks at CodeLabs. So thank you very much.